Hi, how are you? Today we're gonna do new topics over here, okay? Congruent triangle, okay? Congruent triangle. So to prove congruent triangle, okay, we need to review something important, okay? The theorem over here, okay? So we're gonna start one by one today, okay? After finish this old theorem, we can go into triangle congruence. Okay, the first one, take a look over here. During the proof, you will see this one. AB, this is the line AB. This is what measure of AB, totally different. Okay, this is has some numbers. We said 5 or something like that, but this is a line segment AB. Okay, that's the difference. Two lines. Okay, two lines, line segment. Okay, I'm gonna say just two. Okay, I can say segment. Okay, two line segment perpendicular. AB and CD, they are perpendicular. That is perpendicular. If you got this one, if this is given, the next step, don't forget this one. We're going to this next step. You cannot jump 1, 2, 3. Okay, never jump 1, 2, 3. There's always a step. Okay. When you have a perpendicular, you have to go 1, 2, 3 steps. First, you have to say angle CBA, this angle, and angle DBA, this angle, are right angles. You have to say it this way. You have to memorize, okay? These two angles are right angles. Okay, so angle CBA and angle DBA are right angles. You have to say it this way. But you have to memorize the region too. The region is right there. Perpendicular lines. These two are perpendicular lines. Intercept to form right angle. When you intersect these two lines, they create what? Right angles. Okay? Or you can use what? Perpendicular lines form. You can skip this one too. Just what? Perpendicular lines form right angles. It's fine too. Okay? Simply. Or a little more detail, you can say perpendicular lines intersect to form right angles. But I like this one. Perpendicular lines form right angles. Okay, that's the region. Is it okay? That's the region. Because what? They are perpendicular lines. After that, always these two angles are right angles. That's why these two angles are congruent. Congruent. Same measure, same magnitude. Okay? When you measure of this one, they are equal to 90. Maybe when you measure means what? Measure of angle CBA. When you measure, this one got some numeric number, right? Must be equal. We don't say congruent. Measure is some numbers. This measure DBA, when you measure, that is equals 90 degree. Okay, but in this case we use only congruent. Okay, yeah, that's the meaning. Congruent means what? They are equal. Okay, equal in measure. Okay, congruent means what? Equal. When you measure this one, they are equal. Because they are right angles. When you measure, that is equals to 90, right? They are equals. This is a congruent means by equal in measure. It's okay? Yeah, they have equal in measure. So congruent angle DBA. The region is what? Or don't forget, don't skip any word. This is a perfect given, the region, okay? All right angles are congruent. We have to say it this way. So one more thing, when you have perpendicular line is given during the right proof. Okay, you're gonna prove some things when you have AB perpendicular CD for the given, we have to go follow these steps. First one, what is that? We have to say first, perpendicular lines form right angles. After that, these two angles are congruent. The reason is what? Because all right angles, when you measure it, when you check and measure, they are 90-90. That's why they are equal, okay? So all right angles are congruent, okay? If you measure, if you want to measure this one, it's going to be 90. They are equal, okay? That is congruent. So all right angles are congruent, okay? You have to follow this process. That is perpendicular. I'm done this one. The next one, angular bisector. During the proof, okay, during the proof some things, if you got this one for the given, AB bisect angle CAD. This AB bisect angle CAD. Bisect means what? Equally divided by into two angles. This is we said bisect. Okay. But this one we can go next is what? Because this is a bisect means what? Angle CAB. This angle CAB. This angle DAB. Okay, we start the C, we start the D over here, right? DAB, CAB. These two angles are congruent. We don't know the measure, but it's gonna have the same magnitude. That is congruent, okay? It's gonna be equals. So angle CAB equals angle DAB. The reason you have to memorize angle bisector, but you don't have to say this one, an angle. It's just what? Angle bisector divide. Don't forget. Angle bisector divide an angle, this angle, into two congruent angles. You can use two congruent angles instead of halves. It's okay to halves equal to angles equal to, or sometimes we use two congruent parts. Okay, one part, two parts. You can use halves, you can use angles, you can use a part. It depends on your teachers. Okay, when you have an angle bisectors, you have to say the region like this, exactly equal to like this one. Okay, angle bisector divides an angle into two congruent angles, or two congruent parts, or two congruent halves. Are you okay with this? This is angle bisector. Angle bisector is only two steps. Perpendicular line is what? 3 steps. Okay? Don't make it 2 steps. Don't jump from 1 to 3 directly. Okay? We're gonna go 1 to 2, 2 and 3. Perpendicular 3 steps. Angle bisector 2 steps. Are you okay with this? You have to memorize. Another one is what? Segment bisector. This is a segment, but this segment bisects another segment. AC is a segment bisector. This segment bisects DE into two congruent parts, or segment, or halves, same as right angle. When you have AC bisect DE, this is a segment bisector. But if this is given, the next step you have to say this is a bisector, right? So the length of a DB, this magnitude, the other side line magnitude must be equals. We don't know, right, how much length, okay, what the measure, 7, we don't know, but there must be same number. If you want to measure these two, it's gonna be equal, we know that. That's why we use, right, congruent. Okay, so DB congruent BE, okay? There's the region over here. This also, you can skip this one. Segment bisector, that's okay. We have a segment bisector. Divides a line segment or a segment. It's okay. Segment is a line anyway. Segment bisector divides a segment into two congruent halves, or two congruent parts, or two congruent segments. You can use anything, same as the angles. Okay, but you have to memorize this one. When you have the given, okay, segment bisector, you can go directly, okay, two equal sides are congruent, okay, that is a segment bisectors. Are you okay with this? It's okay. This is very important, okay? So maybe when we go into congruent triangle, now you can recognize why we need this one. Okay, don't change any word over here. This one you can skip this one, but you don't have to skip this one. You can memorize everything. This is a perfect region for this segment bisector. Okay, when you have a segment bisector, you can say a segment bisector divides a segment into two congruent parts or two congruent halves and two congruent segments. Okay, you can use any vocabulary there. This is a segment bisector. We just finished 3 perpendicular lines. You have to memorize the region. Angle bisector, memorize the region. Segment bisector, memorize the region over here. Okay, we need this region, okay, to write in 2 column problem. This column you said what? This is all. I'm going to skip this. This is you say left side statement. This is given in your questions, but this one is the region. Why this given? Oh, this is given. That's the region. But from here, this one is what? We have to write a region over here, okay? In vocabulary, in the word, okay? This is 2 column. 1 column, 2 column. We should have 2 column proof. It's okay. Okay, well, I'm going to do, okay, this is statement in your left column. This is regions. This is looking better, right? After that, now we are doing vertical angles. Vertical angles, we have to say these 2 lines are straight. Then this is the vertical angle. If this is not straight, look at this one, not straight. This is not straight. This is not straight. These 2 opposite angles is not vertical angles. Okay? If you want to say vertical angles, this is a straight line. D, B, C is a straight line. Also, ABC is a straight line. Now they are intersect at point at B over here. Okay, this is we said the lines are intersecting at point B. This is C. I'm going to do C. Okay, intersecting. If not intersecting, it's not intersecting, they will make right angles. Okay, angles should be what? Intersecting point. So opposite angle is said by vertical angles. Okay, so using this one, because they are intersecting, you can say these 2 angles are congruent. We already know that. Angle DBA, this angle EBC, because they are what? Opposite angle, right? They are, because what? They are vertical angles. Okay, vertical angles are congruent. We know this one, okay? Vertical angles, opposite angle always equal in measure, okay? This is the region. Perfect region over here. Memorize intersecting lines. Intersecting lines is what? Straight line. Okay? Form congruent vertical angles. Or some teachers, they like to use this one. Some other teachers just what? Forget everything, just what? Vertical angles are congruent. You can use this one too. Well, this is more detailed, nice explanations. Intersecting lines form congruent vertical angles. Many people they like this one in simple because this is very simple, right? Because we know that vertical angles are equal in measure. Okay, that's why vertical angles are congruent. This is okay too. Okay. Most people they like to use this one. Okay, because that's just simple. Okay, simple region is better, right? We did the number 4, okay, but 2 vertical angles. The next one, other one is the midpoint. This is the midpoint. During proving congruent triangles, okay, if this is given, B is midpoint, point B is midpoint. They said B is a midpoint. From this given, what can you make conclusion? Yeah, midpoint, left hand side, right hand side, 2 lines are equal in measure, right? So BD congruent BC, right? We start from BD, BC. That is better. Or you can use a CB, BD is okay too. But much better is we start B to the left, BC, B to the right, BD. That is better, okay? Now it's time to memorize the region. When you got midpoint, you have to say this one. This is actually, don't skip any word. Okay? A midpoint, you don't need to write just midpoint or the midpoint or midpoint, doesn't matter. Just the midpoint divides line segment or line segment. Okay, use this line segment. It's okay. Midpoint divides a line segment into 2 congruent halves, or 2 congruent parts, or 2 congruent same usual segment. You can use anything. Okay, just memorize, or you can use. Okay, it doesn't matter. A midpoint divides a line segment into 2 congruent halves or 2 congruent parts. But sometimes we use our symbols over here. A midpoint, take a look. How can you find the symbols? A midpoint divides, they use this one, divides a line segment into 2 congruent, or 2 is okay too. 2 congruent use a symbol. That's just congruent halves, or 2 congruent parts, halves, or segment. Use these symbols. Okay, you can use these symbols. It depends on your teachers. Okay, but many teachers they like to use this one. Okay. That is a midpoint. Okay, during the proof some congruent triangle, if you got midpoint, you have to say this way. Okay, that's the next step. From here, for the given, you can make conclusion the next. That is the midpoint. You got the class work, right? You have to memorize this one. Now another vocabulary is what? Altitude. Wow, this one is 4 steps. Altitude has 4 steps. That means you can go here. You can go here, here. Don't go. You can go 1 to 2, but 2 to 3, and 3 to the 4. When you have an altitude, there are 4 steps. Don't skip any step. You cannot jump because that's the rule. When you have altitude, this is AB is altitude. They said over here, okay? If they said AB is altitude, but that's given in the questions. This is the altitude. By definition, what is altitude? Altitude means what? This line AB and the base is what? Perpendicular, right? You have to say this one first. That's the second step. You have to say this one. But you have to memorize the region. Altitude goes from a vertex of a triangle from here. That is a vertex of a triangle. Okay? And is perpendicular to the opposite side. Okay? Perpendicular is what? Perpendicular, right? That is perpendicular, isn't it? So over here, I'm going to use this way. An altitude goes from a vertex of right triangle. I'm going to skip this one. Triangle perpendicular goes to perpendicular ly. Okay, I like this one. This is my region. Perpendicular to the opposite. I'm gonna write it one more time. But this is okay too. But most of 99% they use this one. Altitude or altitude we skip. Okay, altitude goes from the vertex of a triangle. You can use triangle perpendicular to the opposite side. Okay, or you can use just opposite side. It's okay too. Okay, or if perpendicular instead of using, you can use this symbol too. But I like this one. Okay, so instead of is perpendicular, use this one. Perpendicular. Okay, perpendicular to the opposite side. Perpendicular to the opposite. That's just step 2. You have to memorize this one. If you're perpendicular, you're gonna follow the same thing over here. Perpendicular, where is it? Over here. Where is it? Perpendicular. Here, right? Perpendicular. Now you're gonna do the next step. Same step because you got the perpendicular. Same as this one, okay? This one, not the next one is what? Same as before. The angles, these two angles, angle CBA, angle DBA are right angle. You have to say this one second. From here, right? Perpendicular, same steps. So perpendicular lines form right angles. You can skip this one. That is better. Okay, perpendicular lines form right angles. That's just simple, right? Now same as before. Now these two angles are congruent because what they are right angles. Okay, right angles is equal in measure. That's why. Okay, the reason is what? Same as before. All right angle. Don't skip this one. Okay, we need all. All right angles are congruent because they are equal in measure. When you measure this right angle, they are all 90 degree, 90 degree, 90 degree. Okay. So this is overlap, right? From here, perpendicular 3 steps. We need one more. When you have altitude, we go to perpendicular. The next is follow the perpendicular steps. So altitude is actually about 4 steps. Okay, don't go this one directly. Okay, that is the altitude. Anyway, you need to memorize all of this one. Okay, I think you need the time to memorize all this given. Okay, without memorize this one, it will be trouble. Another one is a median. Wow, median is 3 steps. Altitude 4 steps. Median is 3 steps. Perpendicular is what? 3 step too. 3 step. STEPS. If this is given, AB is median. This line is not altitude, just the median. What is the definition of median? When you have a median, the triangle. Median is what? Line drawn from vertex to the what? Midpoint of opposite side. This line is called, this midpoint, called median. Okay? There are many median in polygons. This is a median in in a triangle. The next median is where is it? When you have trapezoid, midpoint, when you make the line, also this is a median in trapezoid. Okay, median is what? This is the midpoint. They are equals. This line also is called the median. But this is what? In trapezoid, this one is in triangle. That different, okay? This is the median. I like this one. This figure is what? In general, right? Okay, so when you have a median, we have to go second step is what? You have to say point B is midpoint. Because median is what? Connect to what? Midpoint, they are what? Connect to midpoint of opposite side. That's why we have to say midpoint over here. That is important. Very, very important. Okay. What is the meaning of median? This is median. A median goes to from vertex of triangle to the what? Midpoint. That's why this is said median. This is connect or joining to a point of what? Midpoint of opposite side. This is opposite side AB. This is C from here opposite side M. That is midpoint M. You have to memorize this one, okay? Median goes from, or you can say this one, median is the segment drawn from the vertex. Instead of goes, you can use this one. Okay? From vertex of a triangle to the midpoint. Many people, they like this one of the opposite side. Okay? Just to explain, median is the line segment drawn from a vertex of a triangle to the what? Midpoint. But this is okay too. Goes from here to, okay, from to the midpoint of opposite. Always you need the midpoint of opposite side. This is okay too. You have to memorize, okay? Either of this one. After that, finally you make a conclusion, because this is the midpoint. We already did the midpoint over here. Where is the midpoint? This is the midpoint. When you have a midpoint, you can say these two sides are congruent. Okay, now we got the midpoint over here. Midpoint, you can say these two sides, AM, MB, or MA, MB, or over here, this midpoint, BC and BD, they are congruent. It's same as right definition of midpoint. Okay, midpoint divides the line segment into two congruent segments or halves or parts. Okay, so every definition of every definition has their own region. Do not switch the region. Do not change. Do not use your own region. Okay, every region should be a formal written in textbook. This is they are all formal. This is a formal too. Okay, do not use what any other region. Okay, all right, that is the median. The next one, isosceles triangle. If the question said yes, angle CAB is isosceles. CAB is isosceles. What is the definition of isosceles? Definition of isosceles, what is that? What is isosceles? Definition of isosceles. Isosceles, triangle has two congruent sides. Or this is what, when you have an isosceles, you can say, okay, this side leg and leg, okay? You can use the two congruent legs instead of side. It is okay? That is isosceles. So isosceles is given. Now you can say these two sides are congruent, isn't it? That is the definition. That is the definition. That's what we said. Segment AC, the side AC and side AB must be congruent. You have to say this one. Why they are equal? That's the reason of here. An isosceles triangle has two congruent side or leg. Okay, that's the reason. Don't angle over here, right? In isosceles, two base angles are congruent. That is not definitions. Okay, isosceles are only what? Two opposite side. Okay, congruent side. Two legs are congruent. That is definition of isosceles, not two angles congruent. Okay, only side. Okay, only side, not angles. Using this side, they are equal. This side is equal. This side, they use this side. This side equals. Now you can say these two angles are congruent. Because what? You can say angle ACB, angle ABC is congruent. The reason is what? In a triangle, congruent angles are opposite of this. I'm gonna write one more. In a triangle, the angles opposite congruent side. Okay, this side congruent side. Okay, opposite angles are congruent. This is perfect. I'm going to congruent. Okay, use this one. Okay, this is a little weird. Okay, in a triangle, the angles opposite congruent side. Opposite congruent side, opposite angles must be equal. Okay, they are congruent. Okay, just give me 1 minute. Okay. Okay. You guys have a 5 minute break. Okay, just give me 5 minutes. Okay, I'm gonna pause this. Okay, now let's resume our class. Okay, everybody's there, right? Okay. All right, isosceles. Okay, so definition of isosceles is what is that? Two congruent side. Okay, yeah. A triangle, isosceles triangle has two congruent side, not angles. Okay, two congruent side. That is the original definition of isosceles. Okay, using these two sides congruent, now you can say additional more the angle. Now going into angles. Okay, the angles opposite congruent side. Okay, use this one. Okay, this is a perfect one. Use this one instead of 3. Okay, in a triangle, the angles opposite congruent side are congruent. Or you can skip this one. You know that it's already what? Triangle. Okay? Just what? The angles opposite. Okay? This we don't need this one. Angles opposite congruent side are congruent. That is isosceles triangle. The next one over here, this is very important. When you have supplementary angles. What is supplementary angles? If you have one line over here, straight angle, we have two angles out there, angle 1 and angle 3. These two angles is what stand on straight angles. This we said angle 1 and angle 3 are supplementary. Right? Or you can say angle 1 is supplementary to angle 3. Right? You can use either of this one. Is it okay? Why they are supplementary? Why they are supplementary? Because what? These two angles stand on linear line. That's why angle 1, angle 3 are linear pair. Angle 1, angle 3 are linear pair. That's why. Okay? Now, you have angle 1, angle 3, supplementary. Angle 2, angle 4, supplementary. You have to memorize. This is okay. Angles that form linear pair are supplementary. Okay? This is fine. Another good reason over here, another one over here, just simply. Linear pair, you can say that angles to stand on what? On straight angles, we said linear pair form supplementary. Okay? This is fine too, but this is okay. Just a simple word. Linear pair form supplementary angles, but better usual angles. That's why they are supplementary, okay? But it depends on the teachers in the school. Most of the teachers, they like this one. Simply, okay? But this is more detail, is fine too. Angles that form linear pair, because this is plural, right? Two angles. Angles that form linear pair, we have two angles which stand on linear line. This is a linear pair. We said they are supplementary. We don't say 180 degree, okay? That is a measure. Okay? We don't say 180 degree. Okay? 180 degree is a measure of angle 1 plus measure of angle 3. That is equals to 180 degree. Okay? That's a measure, but we don't use a measure, okay? We just use a congruent. Congruent means what? Same magnitude. So supplementary means what? When you measure this one, okay, when you measure, if you want to measure this one, it's going to be 180. But we don't measure. Okay, before measuring, they are supplementary. Okay, that is congruent. Okay? But this is a given. Angle 1, angle 2 is a given. But we're going to prove, right? Angle 3, angle 4 are congruent. Yes, angle 1, angle 2 congruent. The other angles, okay, 180 minus angle or 180 minus angle 2 must be equal, right? Yeah, that's supplementary. So, we're going to prove this one from here. 1, 2, 3. So, first we have to say angle 1, angle 3 supplementary angles. Or you can say angle 3 is supplementary to angle 1, right? So instead of this one, because the angle 1 congruent over here, so angle 3 is first. Angle 3 is supplementary to angle 1. I like that one, okay? From here, angle 3 is supplementary to angle 1. Or angle 4 is supplementary to angle 2. I like this one. You can use this, is okay too. This is better. Okay, angle 3 is supplementary to angle 1, right? Because they form supplementary. But it doesn't matter, okay? Some teachers, they use this one. Some others, they use this one, okay? It doesn't matter, nothing different. It's the same thing. But the reason you have to use either of this one. Okay? Just one. Angles that form a linear pair are supplementary. That's fine. But over here, angle 1, angle 2, they are congruent. Over here, right? These two angles congruent. The other two angle. This angle 3 is what? Supplement of angle 1, right? Angle 3, we said supplementary to angle 1. Angle 4 is what? Supplementary angle 2. Because they are equals supplement of angle 1, angle 2, still congruent, okay? That's why they use this one, supplement. Okay, supplement angle. Don't say angle, just a supplement of congruent angle. These two congruent, we know that is given. Angle 1, angle 2 congruent. That's why these supplement angles must be congruent. So this is a better expression, right? Because we know that angle 3 is a supplement of to angle 1. Angle 4 is what? Supplement of angle 2. Angle 1, angle 2 congruent. the other supplement should be congruent. Okay, so that's why the region over here. Memorize supplemental congruent angles are congruent. That's perfect. There's no other region. Okay. When you have supplementary angle, complement also same things. You can use a complement. I'm going to try this one complement. Complement, this is the angle 90 degree. We have two angles there. Another angles 90 degree, two angles there. This is angle 1, this is angle 2, this is angle 3 and angle 4. But angle 1 is not equal to angle 2, right? But the only thing is what? Angle 2 congruent, angle 4, I'm going to write over here, okay? This is a statement. The next one is the regions. You have two columns. First one is given. This is given. Angle 2 congruent, angle 4. That's the given. From here, we're going to prove. This is given. Given is angle 2 congruent, angle 4. We're going to prove this one. Prove what? Angle 1 equals to congruent angle 3. Right? I'm going to make a little smaller one. Angle 4 is small. Deliver? Okay, that is angle 2, angle 4, very small, right? Congruent. Angle 1, angle 3, big. Okay, anyway, they are complementary, right? So over here, this is right angle. Okay? Now we can say angle 2 is what? Complementary to angle 1, or angle 1 is a complementary to angle 2, or angle 1 and 2 are complementary. But it doesn't matter, okay? But I'm going to use this one. Angle 1 is complementary to angle 2. Same column, same region. Angle 3 is also complementary to angle 4, right? What's the region? What's the region? Over here, angle that form linear pair are supplementary. This is what it is. Instead of a linear pair, angles that form 90 degree. No, you cannot say the measure angle form or what? Right angles. It's okay? Right angles that form right angles, these angles are complementary, okay? Not supplementary. T-A-R-Y, complementary. Now, finally we can say angle 2, angle 4, these two angles are congruent. They are the complement, not supplementary, right? So angle 1, congruent, angle 3. The reason is what? Complement of congruent angles are congruent. I'm going to use congruent, the word. This is also congruent, okay? That's the regions. So you have to memorize all the region. I hope you guys okay with this, okay? There's a lot of things you have to memorize. Okay, when you have the supplementary angles, when you have a complementary angles, so what's the next step? You have to memorize this one. Then you don't have to hesitate. Okay, where to go? The next one. Another theorem of here, addition postulate. Just so you can say addition. That's why you don't have to write, okay, always postulate. Addition is about postulate here. This is a statement. That is the region. When you have this one, AB congruent to DC over here, the right over here, okay? AB congruent to this, these two sides is equals. But we're gonna prove AC congruent BD over here, right? These two sides equals. You're gonna add what? Same length over here, okay? This is same length. So we have AB over here. From here to here, BC. That is X. That is AC, okay? The next one, B to C to D. From here to here, also X. This side, BD. It must be congruent, right? Because this side is equals. You're going to add what? Same length of X. It's okay? Okay. So from here, AB, BC over here. From here, AB and BC, I'm going to use different colors. We have a AB, CD, they are congruent. But you're going to add what? Same length. But you have to say this length BC, the other length BC. This is the same length BC, BC, but there must be same length. You have to say this one. But this BC belongs to over here. This BC belongs to the other one. Okay, we're gonna put what? Two lengths equal. We're gonna attach over here. That's why we have to say these two lengths are equals. This is we said reflexive property. BC, this side BC equals, the other side BC, they are equals. So this is wrong, okay? I'm going to use this color. Just what? Reflexive property. Reflexive, right? I'm going to check it out. Oh, okay. Just give me a minute, okay? That is a reflexive. Nobody said reflective. Just give me a minute, okay? Just give me a minute. I'm gonna. Okay, I did wrong. XI, but yeah. Reflex FLEXIB. Okay. Reflexive property, okay, not reflective. I don't know what happened over here. It's okay. REFLEXIBE, okay, that is reflexive property. Reflexive property, what that means? Equal itself, right? This length is same length. That's why equal itself is said to be reflexive. But you don't have to explain, just why reflexive property is the best answer, okay? So this is the quantity. Reflexive means what? Quantity equal itself. Okay, this is reflexive. So BC equal BC. Say this, but this BC belongs to here. The other BC belongs to over here. Okay, same length. We're gonna attach this one in the other two lengths. That's why we need this one. This is reflexive. Now we're gonna add this one. AB plus BC over here, right? AB plus BC, okay, that's the line segment. AB plus BC, that is addition, okay? When you add this one, AB plus BC, DC plus BC, okay? To the left equal, to the right equal. When you add this one, they are still congruent. That is the addition postulate. Okay? This is we said addition postulate. Just the addition is okay. Okay, additions. We don't need this one. The next one. What is the AC? From here, we said right, sum of these two, sum of this equal, but AC is what is there? AB plus BC. You have to say this one, okay? AC equals what? AB plus BC. One more times. BD equals what? DC plus BC, isn't it? Right? This one is AC, this one is DB, right? It's okay. But these two lengths are equals. So the other length is equal. So put this number into the what? They are equal, okay? Because this is equal, put this number into the here. You can this one into the here or this one into the here, right? Because this is the AC. So instead of a DC plus BC, what they are congruent instead of using what AC over here. Right? That is substitutions. Okay. So this one is AC is what sum of each part. This we said partition postulate. Okay. So AC equals what divided by each two part, right? So partition postulate what the whole is sum of each part. Okay, that is the partition postulate. But you don't have to explain this one. Just what partition postulate is okay. Just what partition. After this, because they are equals, from here they are equals, we can replace with AC to the right side. Okay, so that's why AC congruent to DB. This is our proof. Okay, using substitutions, or you can just property of congruence. Okay, because they are congruent. Just memorize this one. When you but substitution is okay. Okay, just substitutions. 100% of teachers that like just the substitutions. Another one over here. It depends on your teachers, but sometimes we skipped a lot of steps over here. This statement there. This is equal, right? Use this one. AB plus BC is what is there? AB plus BC is what? AC is, right? You can go this one directly over here. Skip this 3 too. AB plus BC is what? AC. DC plus BC is what? DB, right? BC plus CD is what? DB, right? You can go jump over here. So forget up this two. Just what? This one is addition from here to here. The region is what? Just you can addition. Use this is the addition over here. Do you understand? I'm gonna okay. This is okay too. Depends on teachers, but many teachers like too. I'm gonna use another different. First step. AB congruent DC. That's fine. Second way, this is given, right? Second is what? BC congruent, and BC that is reflexive. Third one is what? AB plus BC. AB plus BC. Okay, I'm going to do the first one. AB plus BC. That is congruent. DC plus BC, right? This is the additions. You can say, or AB plus BC is now what the AC, isn't it? And congruent DB, right? This is the second method. Third method, more simple. AB congruent DC. Second one is BC congruent BC, that is reflexive. Third one is what? Add this one, go to a directly over here. When you add this one equal to the AC and the DB. Only 3 steps. This is reflexive. This is given. This is addition. You can use first and second and third. There are 3 different proofs there. This is more detailed using partition postulate. Okay? But many people, many students, many are not students. Okay? Many teachers, they like to use this one. But simple proof is better, right? This is very complicated. Okay? There are how many steps? 5 steps. This is 3 steps. The other one is also 3 steps. but it depends on your teachers. Jericho School, they like to use this one. Plainview, they like this one. Sunset, they like this one. It depends on your school, okay? You have to check it out when you go to a September semester, okay? Another one, subtract postulate. From here, given they are equals. From here, we're gonna prove right these two sides now congruent. That's why we subtract this one, right? Same length, BC, the other side. So this is given, and also you have to say, right, BC, this side BC, the other side BC, they must be equal, right? So this is also reflexive, FLEXIV. Okay, reflexive. I'm gonna select this. Reflexive. You're gonna subtract. Okay, this is what subtraction. But this one is actually equals to how much? AC, right? It's okay. AC equals what is that? AB plus BC, isn't it? AC equals what? AB plus BC. DB equals B, DB, okay. BC is what? DB minus, no. This is subtraction over here. AC equals what? AB plus BC. DB equals what? DC plus BC, isn't it? Is it okay? So how do I get the AB plus BC? AC, that is the partition postulate. This is a bit weird one. Okay, just give me 1 minute. Okay, I'm gonna correct this one. Substitution. So okay, actually this one will write over here. Okay, AB equals what is it? AC minus BC, right? Okay, AC minus BC, that is AB, and DC equals my congruent DB minus BC, right? Okay, but this is this side because they are equal. Now you can say AB DC, right? But this one a little weird. Okay, but I like to use this one because that is a little subtraction, a little weird. So I think you can go this way. From here, subtract AC minus BC is AB, right? AC minus BC is AB. You can go jump over here. Okay, using what? The reason is what? Just a subtraction. Because this is partition postulate. Okay, using this partition postulate instead of this one, you're gonna use this one. Partition postulate is what? Whole is equal to a sum of this one, or this part is what? Whole minus another part. So you can use, instead of this one, you have to use this one. Okay, AB. This is a part congruent whole. This is a whole length AC, right? Whole minus the other part is what? BC. This is also a partition postulate. Better use this one instead of this one. Okay. The next one is over here. DC part is what? Whole is DB minus BC. This is also a partition postulate. Partition postulate is what? Whole is equal to the sum of each part. That is a whole. That's partition postulate. Partition, right? Also what? A part is Okay, but okay. Yeah, this is a whole anyway. So that maybe you can this one is what inclusive this one, right? That means what same things. After that, these two are equals. Substitute. Okay, because they are equals, this is also equal, right? That we said substitutions of congruence. Okay, just the substitution is okay. But this one a little addition is okay. There's a partition is what this one equals, this one equal, this one equal, this one equal. That's fine. But subtraction a little bit different because this is a subtraction there. Okay, so you have to express what this partition instead of this one. We better use this one. Okay, a part is what whole minus the other part. Okay, that is also a partition postulate. Okay. Now the parallel line. We said parallel line over here. When you have parallel line, you can say these two angles. What are these two angles? Alternate interior angles. Okay, they are already congruent. We know that we did already, right? Two parallel line there. We have a transversal. These two alternate interior angles are congruent. This is very important. This is very useful to prove right triangle or any proof. You can go directly because they are parallel alternate interior angles equal, but there's a reason over here. Okay, but some teachers they like alternate on this one. Alternate interior angles are congruent. That's enough. Very simple. But some teachers they like all of this one. So you have to read. If parallel lines are cut by a transversal, you have to write down this one. If parallel lines cut by a transversal, then alternate. You have to write down. Okay, then alternate interior angles are congruent. This angle, interior angle, this angle, alternate interior angles are congruent. Okay, that's the whole reasons. You remember it. Okay, so many teachers they like to use everything, or some teachers are simply what alternate interior angles simply are congruent. Okay, because we know that they are parallel line and the transversal. We all know that everyone knows this. Okay, so you don't have to explain that. But some teachers still they like to explain when parallel lines are cut by a transversal. Okay, use this one. Okay, cut. Alternate interior angles are congruent. Okay, this is very okay. Always it happens. Okay, it's a very strong proof. Okay, corresponding angles is okay too, but not many used. Anyway, corresponding angles well, okay, matching corner. Okay, this is same parallel line. This is transversal. These two angles is what? Matching corner angle, which is a corresponding angles. Okay, it's the same thing, same region. We have to write down same region over here. Then corresponding angles are congruent. Okay, alternate angles congruent. Okay, corresponding angles are congruent too. Okay. The next one is the alternate exterior angles. We already did. Okay. Opposite side. That is alternate exterior angle outside the parallel line. Okay. DE, FB, they are parallel. Okay, we can expand this one. This is transversal. Okay, I'm going to use different colors over here. That is a transversal. Okay, CFB, this angle, and AED, not this one, okay? CFB, this angle, right? CFB, this angle. And the other AED, this is exterior angle, right? Okay, this is okay, also sometimes useful. because the two parallel line, I'm going to do this two parallel line over here. We have a transverse over here. Okay, these two angles are exterior angle. Okay, alternate exterior angles. Okay, are congruent. Alternate interior angles. This is what? Alternate interior angle, right? These two angles, alternate interior angle. These two is what? Alternate exterior angle, okay? Always are congruent, equal in measure, right? Memorize this one, okay? Maybe you might have some example after this, okay? Okay, congruent polygon. I'm going to skip this one. Congruent polygon we can do later. We are going into triangle over here. Congruent. Congruent means what? Corresponding sides are equal and also what? Angles also equal, right? That is congruent. Only angles congruent, side we don't know, side different, that is similar. Okay? So this is, we said congruent is the same shape, which is corresponding 74. Take a look like S is 74 degree, right? 41, R may be 41 degree. Okay? Okay. So just by using the side, you can decide the angle of T. Angle of T is how much? 180 minus sum of these two angles. These two angles is 115. 180 minus 115 is 65 degree. It's okay, but that's not big deal. Over here, these two triangles are congruent. That's not proof. Congruent means what? Same length, same angles. Okay? What is similar? Same angle, different side. Okay? So here, 63, that might be 63 over here, okay? That the corresponding side looks like the same size. Okay? So 3x plus 93 plus 63, they're all 180. Is okay? So what is the value of x? 3x plus 93, 63 is what is the 156 equals to 180. Subtract 156 minus 156 there, that is equals to 24, right? When you divide it by 3, x is 8. So this is x equal 8. So this is what, 24 degree, right? But this is corresponding side, right? LM congruent SR, isn't it? That's a corresponding side. They must be congruent. So that is a measure, okay? But measure is what? This is congruent. Measure is just the LM is a measure, right? There's no sign over here. That is a measure. This measure is how much? 43. The other measure, SR, equals how much? 3x plus y, that is equals to 43, right? Compare what's the difference? LM and LM. That is the measure. This is just a line segment. Okay? Before measure, okay? Before we didn't measure. Over here, x equals, we know that 8. Put this number 8 there. 3 times 8 plus y equals 43. 24 plus y equals 43. When you subtract 24 both sides, so y equals, what is that? 19, okay? That's the length of y. Okay, we're gonna do this one. I'm gonna try, okay, one proof of it. Take a look. This is a proof. Okay? Because this is a very simple proof. I'm gonna try to prove triangle congruent. To prove congruent triangles. First one, you have to show that side, all side equals. That means the side congruent, side. Okay, this side equal, the other side is equal, and this one equal. This is what? Side on the other side. Okay. Second one is what? Side angle side. to prove congruent. You have to memorize, okay? The next one is what? Angle, side angle. The last one is what? Angle, angle, side, okay? Only 4 over here, okay? Another one is what? In right triangle. If there is a right triangle, in right triangle, you can say hypotenuse leg. But we're gonna do this one, okay? Don't worry, this one. But side angle, angle side, or side angle is not working. Forget about this one. Instead of this one, we replace with the hypotenuse leg, okay? So first we're gonna focus on this 4 to prove that there are 4 different ways to prove congruent triangles. But this is given. If this is congruent, you can use 2 columns over here. Statement, regions. I'm going to use a capital A and capital R. That means a statement and regions. You can use, right, the first letter. The first one from the graph, that means given, okay? So first one, LP, this side, congruent, and all, right? That's right. That's the given. Second one is, I'm going to do all side. This side, congruent, MN, okay? So PM is actually congruent, MN. This is also given. Third one is the LM, also congruent MO, right? That's a given. All given over here. But we already got 3 sides. This is side, side. All 3 sides is equal. So you can make conclusion over here. Triangle LPM congruent triangle ONM. What's the reason? This one. So you can say side congruent is actually corresponding the other side. That's the reason. Okay, now we can make conclusion over here. These 2 triangles are congruent. Is it okay? But we're gonna do this one later, okay? One more times. Just I'm gonna show you how we prove, okay, triangle congruent. Okay, if we have a congruent, corresponding side always equal, you can write down, okay, AC congruent DF. 1. 2 is what is that? CB congruent FC, corresponding side. So the side first, AB congruent DE. Okay? What are the other 3? Angle A congruent angle D. Angle A congruent angle D. And angle C congruent to angle F. Angle B congruent to angle E, okay? They are corresponding angles, all congruent. Angles congruent, side congruent, okay? That's it. Method to prove triangles congruent. I told you already, okay? If 3 sides, okay, they are all corresponding side, only side, congruent, maybe you can use this one. This side SSS, that means 3 sides, this is also 3 sides. Corresponding side is what? Here and here, they are congruent. Or just what? SSS, side, okay. This is the side means what? You have to write down side equals side, same thing, okay? You can prove it this way. Then the triangles are congruent. Or 2 sides is equal, between the angles also equal, okay? This is also congruent. The next one, angle side angle. One side is equals, okay? On this side we have 2 angles, angle. So this we say angle side angle, okay? Angle side angle, okay? If this is congruent, this is equals, they are congruent. Angle side angle. Another one, angle side. Angle, this problem here, angle side. This is the angle side. This is also what angle side. They are congruent. Also, the triangles are congruent. The next is hypotenuse leg later. Okay. Over here. After this, we'll finish. Okay. Example 1. This is one of the triangle proof. Okay. I'm gonna do. Okay, number 1. Okay, number 1 is okay. So there's a 2-column proof there. Statement. Reasons. The first we have to write all given there, okay? MPO straight. This is the MPO straight. That's why we said these two angles are vertical angle, right? If this is not straight, that is not vertical angles, okay? I told you to say vertical angles, these two lines is a line, okay? Alright, straight line. LPN straight angles. This is given. From here, MO bisect MO. You write down this, okay? Segment MO bisect LN. MO bisect LN. So these two sides are congruent. That's the meaning, okay? That's another given. So from here, we have to prove what? Okay, we have to prove triangle. We have to prove. There's no proof there. They didn't say proof. Okay, I'm gonna given this one. We're gonna prove triangle MLP congruent triangles OPN. Okay, or ONP. Okay, MPL. Okay, MPL. MPL is better. We're gonna prove this one. So write down over here, side, 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 or side, angle, side, angle, side, or angle, side, angle. So we're gonna choose again one of this one. This is side. Intersecting vertical angles congruent. We got one angles. Angle LMP, it's given, right? LMP, this angle and the NOP angles. This what is the angle side of it? Can you see that? Angle side. Right? This is the angle angle side. Follow the order, right? So we have to go this one. So this one is what? Angle LMP congruent angle NOP. Sorry. This is given too. We got one angle over here, okay? Now we can write 10 angles. The next one, other angle, you have to show that these two angles is what? Vertical angles. We can go directly. Angle MPL congruent angle OPN, okay? OPN. What's the reason? Just before we use this one, right? Intersecting lines. Okay, intersections form two congruent vertical angles. That's the reason, right? Or just what? Vertical angles congruent. Or just what? Vertical angles congruent. Okay, so I'm gonna follow, right? Just before. Intersecting lines form two congruent vertical angles. That's the reason. Okay? Now we have to show that this side is congruent. We know that NP, this one equals what? NP, right? What's the reason? Because there's a bisect. What is this one? Segment bisect, okay? Segment bisect divides a segment or line segment is okay to a segment into two congruent parts or halves. That's the reason. So we got the y angles side of it, right? Same order to the y clockwise angle, side. We already got angle, side, everything. Now you can make conclusion triangle MPL, congruent triangles OPN, right? The reason is what is there? Side, angle, side, congruent, or angle, side, congruent, the other angle, side. Okay, so you have to prove this way. Today we have only one example there. Okay, we'll continue example next time. A lot of example there, but you have to memorize how we write the region, how we follow the steps. Okay. So if you have any questions, you let me know. Okay. So the next one over here, REFLEXIV. That's correct. I did wrong. Reflexive, right? Yeah, REFLEXIV. That's okay. Okay, that's fine. Okay, so I'll see you next time. Okay, we'll have a lot of practice on congruent triangle proof. Okay, next time. Okay, there's no homework. Just memorize all these steps and region. Okay, you need to memorize. That is most important. Okay, I'll see you next time. Okay, everybody has a good night. I'll see you next time. Okay, bye everybody. Okay, I'm gonna put this one on your note. Don't worry, I'm recording this one on YouTube. Okay, you can watch TV. Okay, right after this, post this one on YouTube. Okay, you can see the video. Okay, or I'm gonna send out this note to you. Okay, I'm gonna save this one then. I'm gonna save this one and I'm gonna send out to you to your email. Okay, and with a link to. Okay, because this is very important. That's why I record my video. Okay. Okay. Thank you, everybody. I'll see you next time.